In this session, I wanted to show you how to fold an icosahedron modular. It is a fun activity and it incorporates a lot of geometry concepts, so we are going to go slow. The first thing you need is a piece of circular paper. If you don't have a circular paper, you can get anything that is circular, say a tin of tomatoes, and you can just trace it onto any colored paper, and then you cut it out. With a circular paper, you need to fold it in half. And if you're going to teach this to children, you need to introduce the language. We know that when we fold this in half, this is what we call a diameter. You find another spot, you can turn a piece of circular paper, and you do the same fold. Again, this is a diameter, but because I've already folded two folds, I can locate the center. And I'm going to point this and write it into the center. And you do this as you go with introducing the language as you do the fold. What you need to do now is to fold the paper by making sure that the circumference touches the corner. You make a straight fold. Now, we know that that is your major segment, whereas this little bit here is your minor segment. You then need to fold this side of the circumference, making sure it touches the corner in the center here, as well as you make it as sharp as possible on this corner here. So a little bit of a coordination is needed. You make that fold. The circumference touches the corner, the center, and then you have got a corner that is really sharp. And guess what you just made? You just made a cone. You do the same thing by folding the other side, making sure that you've got a pointy sharp corner on one end and the other end. What you just fold is an equilateral triangle. If you fold this tip so that it sits joint the center midpoint, you just folded an isosceles triangle. An isosceles trapezium. If you're not sure whether this is a precise isosceles trapezium, what you can do is to fold your equilateral triangles in half. Making sure you get the midpoint here, and then you can just do exactly the same. If I fold this piece on this side, I'm going to get a parallelogram. And if I teach it in class, I would actually get children to write the words on it. I fold this on this side, I just make myself a similar equilateral triangle. If I fold it open, I can see the original equilateral triangles. What I need to do now is fold this on the top and then flex it back until it reaches the center, and I make a parallel fold. I do the same, and I can make a parallel fold. I do the same on this side, and I make a parallel fold. Now, if I open it up, if I pull this up together, I make a triangular base pyramid. Because I've just folded all these sides, I can fold this to the center. I make a different isosceles trapezium. I make another isosceles trapezium by doing the same fold, making sure that the tip touches the center. And I do the same here. Guess what I just made? I just made myself a regular hexagon. And children can see that a regular hexagon is made up of 6 small equilateral triangles. I can then pull this up and tuck this in the inside flap. I pull this and tuck it inside. Guess what I just made? This is a truncated triangular base pyramid. If I have 2, and I can join this together, so I can just join one face to the other face. I use a sticky tape. I can stick it together. I just make the first face. If I make 20 of this modular, I can make myself, join it together, I can make myself a icosahedron.